First, you must realize that you have no idea before you can know the idea. We scan across all the frequencies if we want to learn anything new. Let us begin.
What has physics done for me lately?
Furthermore, the equation E is equal mc squared.
We have now acquired a fateful power to alter and to destroy nature.
That's like when you're in physics and you go to Dreamworld saying, oh, this is a physics excursion.
Science. What is it all about?
The whole of human history all falls in the dust of one stroke of the nail file. You can't really get to grips with evolution unless you realise what an enormous amount of time.
Our own planet is only a tiny part of the vast cosmic tapestry, a starry fabric of worlds yet untold.
That's right, you tune into what can only be described as the best radio station on this blue dot we call Earth. It is, of course, 4ZZZ, your community broadcaster, be it on your conventional wireless radio by tuning into the classic frequency of 102.1 FM, digital devices such as DAB or smart speaker, listening via the Community Radio Plus app while you're at the gym, or streaming us live from our sensational website at 4ZZZ.org.au. And, of course, you can always listen back to our show. Yeah, I just listened back to our show, I think, on the ingenious on-demand feature also found at that URL. We also now have a weekly podcast of the show for your listening pleasure, which usually comes out on the weekend, curated by Toby, a condensed version of the show without the music, which my mum prefers. Just search for our show name, which is, of course, No Idea, spelt with a K, your weekly dose of science. And joining me for this episode to speak about all things science are two of my favourite science influencers, Peta.
Hello, Max.
Gabe.
Hi.
He's fixed it himself.
Max, it is show number 679 today,
Brilliant.
Which is approximately the number of households that Santa will visit every 0.25 seconds tonight.
They proved that.
Wow.
They proved that quantum physics, Santa could actually visit everyone in time.
That's what I was about to talk about. Because
yeah,
if Santa has to visit each house individually,
Each house with children.
Each house. This study, the study that got the rate to what this would be about 0.25 seconds per 679 households. That's only looking at children up to 10 in Christian households.
That makes
even
sense.
More.
the true believers. Yeah.
Sure, Max. Unless, like you said, he visits lots of houses at the same time, because there was that article put out by some quantum physicists where they went, well, actually, if he's traveling that fast, he would probably spontaneously combust, as with the reindeer, just at traveling at that speed, 0.8% the speed of light, having to go through houses that quickly.
Yeah.
But quantum theory could make it possible because theoretically, if Santa's in some sort of superpositions of all his states at the same time, replacing Santa Claus by a matter wave that exists throughout space and occupies space at the different states at the same time, then Santa would be able to deliver all of the presents all in one go, taking as long as he damn well pleased. 32 hours is about how long it takes to get around.
Job done.
The whole thing.
Yeah.
But yeah, unless he's in quantum states, which would explain why no one's ever seen Santa Claus doing the run.
Because it's both a wave and a particle.
Like we know with quantum particles, they exist in every possible state until they are observed, and then they are only existing in one state. So if Santa was ever observed, then it would take the whole thing down.
Yes,
exactly right. The whole apparatus
So
would come down.
This is the message of this show is please don't stay up tonight to try and see Santa, because if you do, quantum physics says that he will no longer
exist. In fact,
exist.
relying on quantum physics and existing in a superposition of all states at the same time, then yes, a single observation of Santa would take it down, not just for this year, but for every year, because it's not just existing in a quantum state for this one night. It would be constantly existing in a superposition of all his states for octillions of years.
Fair enough.
So don't stay up.
Yes.
Don't try to catch Santa.
Job done. Introduce the show, Gabe. Let's do it.
Well, later on in the show, I've got some 6 tips from science about how to improve Christmas dinner or any other big meal you're cooking up over the next few days. I've also got something about how we may be taught as kids to do something that we're told is polite, but maybe limiting our power. What do you got, Peter?
I've got a couple things. I'm going to talk to you about seafood, which again, timely. Might want to listen in if you're going to be eating seafood over the next couple of days.
Yeah.
And then I'm going to hit you up. This is a Christmas special. This is a present from me to you. We've got a double dose of marine science today, a two-parter. So
okay.
strap in.
Does that mean we can play the sting twice?
It does.
Cool. Gabe will like that.
Good stuff.
I'm going to talk about AI and science research and how it's sort of gaming the system a bit. But we'll get onto that after this.
You know, there's just you know which one I like is.
What is your favourite?
It's not my favourite because Workers' Power's my favourite. Right? But no idea. I've been enjoying that. It's a society kind of show. I just like that. They present it in a really good way. You know, there's just so much good radio content. There's something for everyone.
You know it. You tune in to 4 Triple Z. Show's No Idea, your weekly dose of science with me, Max. We've got Gabe, we've got Peter, we've got this. Shout out from the rooftops. What do you got, Peter?
What lasts forever? What lasts forever?
What lasts forever?
A diamond?
What lasts forever? I mean, it lasts a very long time. I've said the vast plains of space,
Ah, yes.
friendship, and PFAS.
PFAS.
And PFAS. We're talking about PFAS.
Yeah.
So I feel like these are becoming more and more of a mainstream topic, but if you haven't heard yet, they're here, they're there, they're every bloody where. PFAS, or per- and polyfluoroalkyl substances, are a large group of synthetic chemicals that have been used in consumer products since about the 1950s. The main thing you'd probably know them from is their ability to make things not sticky, so non-stick pans, pots, muffin tins, etc. Unfortunately, they're also linked to immune disruption, hormone interference, and increased cancer risk. There are loads of studies that have been coming out over the past couple of years about the real risks associated with PFAS and having it in our bodies. Now, just to quickly throw it off the bat here, scientists at the moment have the primary concerns are with PFAS-laden cookware, so non-stick cookware, especially when it gets over 270 degrees or is scratched. So if you have non-stick cookware that is scratched, please stop using it because you don't want to ingest that. So that's the main thing. But the other places that they've been turning up in, and has been a real, like a significant place that humans have been getting it from, is fish. And specifically in the fish that you eat. So seafood. They're a significant source of PFAS for humans. But one things we didn't know was exactly how PFAS moves through marine food webs, which fish species pose higher exposure risks, and who is actually exposed through seafood? Who's getting exposed to this? Until now, because a group of researchers led from China's Southern University of Science and Technology, QS ranking, please.
102.1.
What?
That's our frequency.
800.
343.
There you go.
And I can also say, ignore the QS ranking because these results have been published in Science.
Oh, that famous journal. Nice.
Yeah, big deal. So how did they do this study? Well, rather than just relying on fish sampling alone, so going to a fish and sampling how much PFAS they had, they actually built a global modelling framework to estimate PFAS exposure through seafood. So they combined a couple of major data sets. First of all, seawater PFAS measurements from 3,000 sites worldwide collected over 20 years, so going in seawater rather than the fish itself. Then marine food web models to understand how the PFAS accumulates up trophic levels. So essentially, if a little fish eats something with PFAS, when they get eaten by a bigger fish, that bigger fish accumulates all of those PFAS as well.
Yep.
So things like tuna or sharks are going to have a much higher level of PFAS because they're very high on what we call the trophic scale, or essentially they're big predators.
Yep.
Big predators are going to have a lot more PFAS.
Don't we then eat the tuna and the shark?
We do then eat the tuna, and you should not eat the shark. And so then they use the food web models, to see where the PFAS are going. And then they used global fisheries catch data covering what fish are caught in what quantities where on the globe. And then they used international seafood trade data to try and track where all these fish are being consumed. Now, on a personal note, I know that international seafood trade data is a little sketchy, dodge. We don't know that much about where fish actually go. But in saying that, this is a rigorous model, so they would have sort of managed for that in their model. So take it with a pinch of salt, but not an ocean of salt.
I always take my seafood with a pinch of salt.
It's salty enough. I don't know why you're doing that. That seems like an odd thing to do. So then they use these computer simulations to predict PFAS concentrations in 212 edible marine fish species, representing roughly 99% of global commercial marine fish production. So that's a lot. Basically, most of it. They looked at that. And they did a bunch of, they actually validated it because they went and measured PFAS concentrations from 150 fish samples across 87 species across 14 countries, so a lot of places. And they were able to validate their model, saying that it was highly accurate, which in my opinion is very, very, very impressive.
Yeah, great.
And so through that, they were able to estimate human PFAS intake through fish consumption by region and sort of trace how it changes. So here are the big findings. Number one, fish caught in Asia and Oceania, including our own east coast here in Australia, had the highest levels of PFAS in the fish. So those fish that were caught. Fish from Africa and North America had the lowest average PFAS concentrations, but the contamination levels where the fish were caught didn't match where the exposure of where they were eaten, right? So even if it's caught in Eastern Australia, if it's not eaten in Eastern Australia, it doesn't affect us. It depends on where the fish is eaten.
Yeah.
So they said that generally that didn't really line up. But if you live in Eastern Australia and you eat Eastern Australian seafood, it's something to watch out for. We have a very high level of PFAS. They also found that, yes, PFAS concentrations increased with trophic levels, so larger predatory fish consistently contained more PFAS. They also said, and this was interesting, they said it wasn't the focus of their study, but they did find that freshwater fish generally carried much higher PFAS levels. They said to more than an order of magnitude higher than marine fish. But it wasn't what they were looking at. So they didn't really expand on it, but they just said, like, hey, just so you know, freshwater fish were significantly higher. And then, yeah, the international seafood trade is shifting these PFAS exposure from higher contamination regions like us to lower contamination regions, which is really interesting. So Europe emerged as a major hub as a redistribution of PFAS. If you know anything about seafood internationally, you will know that Europe is a major place where seafood gets moved around, not just to Europe, but to other countries as well. It's sort of like a midpoint for a lot of places. So they are moving around, even though European fish are not among the most contaminated. So their own native fish don't have that much PFAS, but they're moving a lot around. North America, Europe, and Oceania face the highest daily PFAS intake from seafood consumption, largely due to those trade patterns rather than local pollution alone. So even though Australia has very high pollution, we're eating even more because of this trade. Probably because we're eating a lot of things like tuna, which would have a lot of PFAS in it. The good news is there was a little silver lining here in that they actually detected a global decline in the median PFAS exposure risk following PFAS restrictions under the Stockholm Convention in 2009 and 2019. So it's showing that international regulation is absolutely working, which is fantastic, but it's only over long timeframes.
For the types of PFAS that have been banned.
Yes, many have not been banned still, but those that were banned has actually reduced the general PFAS, which is really fantastic. So it's a really cool, huge study. It just it's a really good show of how having these big data sets doesn't just help for that data. It helps because people can now do these meta-analyses of like 4 different giant data sets to figure out who is getting filled with PFAS and where it's coming from.
It's us.
It's us.
3 physicists at the Technical University of Denmark, they have ranked the types of paper that are most likely to cause a paper cut.
Oh, shut up. Really?
Yeah. It goes out to Izzy.
Oh, shut up.
You tune into 4ZZZ, and the show is No Idea with me, Max. We got Gabe, we got Peter, we got this. Before you get into your weird science, Gabe, Owen, DJ Oz texted in. Randomised is on tonight, so it sees in the Christmas day at midnight. And they reckon they'll be tracking Santa's progress tonight, live from an outside broadcast on the roof of Z Towers. Tune in.
Hopefully with blindfolds on.
Yeah,
so they
tell them they can't look.
So they don't accidentally observe Santa and break the superposition.
That's right. What do you got for us? Some weird science, Gabe.
Weird science. Do I get a sting?
Oh, I just did it.
Well, you're not listening.
I'll do it again.
Yeah, do it again.
Dance every time. Science. Bam.
It's always better the second time. Anyway, we're always taught as children not to swear. Mm-hmm. Clearly, in the case for most Australian children, the teaching doesn't take. But
Didn't take.
we get told it's not appropriate. We get told it's rude. What if the real reason we're told not to swear is because it limits our power?
I know it limits mine.
Really?
I'm going to ask Peter here to do a bit of a physical experiment.
Do we need to have a language warning?
Well, I'll tell you when the language warning starts. Yeah. So what I need you to do is get ready to do push-ups with your feet elevated on the chair, ideally, or just regular push-ups is fine.
I can't hear Peter.
No?
There you go. What's going on?
Yeah, I've muted the mic because she's going to be moving all over the place.
Okay, fair enough.
All right, she's going to go into the push-ups, and while I want you to do it while you're doing the push-ups, I just want you to just say the word carpet. Just while you're doing, just start doing push-ups and just say the word carpet while you do. All right, she's off. She's going now because the question is: the previous research has found that people are able to do better at physical challenges, like keeping your hand in ice water.
Yeah.
She's done. She's done about 5. I think she's tapping out. We're at to 6. She gets a 6. We're struggling. 7, and that's it. We're tapped out with carpet.
Yeah.
The carpet's got a bit strained at the end.
I
so
want
I
to
don't
know
think
what the
you
swear word
fully
you're going
kept
to
the.
use.
Yeah, we'll get to this bit. So we know that people have been able to do certain things, better physical challenges if they're able to swear. The question is how. So this comes to us from Keele University and the University of Alabama in Huntsville. Do you want to guess some QS rankings for those two? Peter's back with us now.
200 and 400.
200 and 400. Peter,
Keele University.
Keele's
I'm going to go
UK.
140.
It's 801 to 850 for Keele.
Never mind,
And
that's my
University
British
of Alabama in
bias.
Huntsville does not have a QS ranking.
Yeah, I didn't guess for them.
The other University of Alabama, the main campus, has a 901 to 950 rating.
Fair.
So
Not bad for their
before we get
education.
you, I'm just letting you recover, Peter, before we do the next part of the experiment to test how swearing might help us with physical challenges. They conducted 2 experiments with just under 200 people, and each of them, they asked them to repeat either a neutral word, so I got you to do carpet, or a swear word while doing a chair push-ups. They had, that's the legs up on the chair and pushing
It was
down.
much harder. I don't know why you made me do the hard ones.
Yeah, much more difficult. After completing that challenge, they then answered questions about the mental state, including things linked to disinhibition. This is the key word they're trying to get at here, which is trying to test with maybe swearing helps us get rid of inhibition that gets in the way of certain tasks, including physical
I wonder if this
tasks.
works as well on people like Australians who swear all the time.
It'd be a good test to do.
I have a
whether it
feeling
has
if you didn't swear that often, just letting one loose probably would feel really good. But for me, it's like an everyday thing. So
Right. They also asked people how they felt, how funny it felt, how distracted they were, how self-confident they were. And they confirmed for a start that people who swore during the chair push-up task were able to support their body weight significantly longer than those who repeated a neutral word, combining the results of the 2 experiments. And then by combining their results with the results of a previous experiment, they found that this difference could be explained by increases in a participant's reports of psychological flow, distraction, and self-confidence. So that's all linked to the disinhibition they're talking about. Having more self-confidence, less distraction, and more psychological flow
I
is
feel like I'd be more confident if I could do more push-ups.
disinhibition. Getting rid of disinhibition. So they're saying there's a lot
Did they
of
get a fitness check
situations.
before they did the task?
No, I think it was just about how many you can do with and without the swearing.
Right.
In many situations, people hold themselves back consciously or unconsciously from using their full strength. They're saying swearing may be an easy way to help yourself feel focused, confident, and less distracted and go for it a little more. They're saying it's a bit of like a free, calorie neutral, drug-free, low-cost, easily available tool.
Maybe
to
don't do it
boost
in the gym when there's
performance.
kids around.
It's like a percent.
Yeah, I mean...
Or do teach them that it's good for them.
That's
in
right.
We've just
moderation.
learned that it's better.
And now they're doing research to see if maybe it could help with things that aren't just physical. They're looking specifically at public speaking and what they call romantic approach behaviors, which we
Okay.
would just call
Ew.
flirting.
Don't do that at the gym.
I saw
Don't do
you
that at
cross
the
the
gym.
bar. Yeah.
2 situations exactly exactly. Two situations where people tend to hesitate or second guess themselves. They want to test if swearing helps in those sorts of situations as well. And by that, you can get at this idea of disinhibition a bit more. If swearing is helping in lots of different circumstances and people are reporting that it's helping with things like self-confidence, then you could
Maybe
link
that's why
that
Aussies
to-
are so chill.
Maybe that's why Aussies are so chill. And you could link it down to this core idea of perhaps swearing helps us with disinhibition, helps us get over our inhibitions when we're doing certain tasks, including physical tasks. And that's what I've got for you, Max. While we're in the
I'm
break...
not doing any more push-ups?
No, I'm going to get you to do it while we're off air.
Yeah.
For the sake of our
What's Peter
listeners.
Just for making me do push-ups.
You going to say,
Yeah, and
biscuits, or what are you going to, what's the
you're going
swear
to
word?
pick whatever swear word you want, and you're going to do another round of push-ups. And on the other side of this track, we will see how many you got to.
Okay.
If no one else can help, and if you can find them, maybe you can hire 4
4 Z. I reckon I can do
Max-
that voiceover. Thank you.
No reverb, you're welcome.
Yeah.
Okay, do it right now.
4 Z.
Nice. You're listening
tuned
to
into
4
4
Triple Z.
You tuned
And
in
earlier on 4 Triple Z, we were testing Peter, putting this latest study to the test, and if swearing can help your physical performance in something like a chair push-up. So you did 7 when you were saying a neutral word. You were just saying carpet. You got 7 push-ups done. We waited a few minutes, and while we were off air, you tried the swearing version. We did film it, and we will post it on our socials. No idea 4 Triple Z, with a lot of bleeping because you tried out a lot of different words.
Oh, I was told to swear, so I did.
Impressed.
Really? I swear all the time.
How did it go?
I think, honestly, because I swear so often, I was more just thinking, like, what should I say here? I wasn't really...
don't think it
wasn't
really
any
helped
sort of
with-
inhibition. It was just like, what word should I use next?
And you got to
7.
7.
Exactly
Bang
the
on.
same. But maybe I should be using words that I don't use that often.
Yeah.
Maybe.
So maybe that would be it.
And it was a second set within a few minutes, so hitting the same number's not bad.
Yeah, look at these arms.
Cool. Give it a go.
Listeners, my biceps are huge. Let's just get one thing straight.
Get that
I am
mental picture.
swole.
Let's do it.
Beefcake extraordinaire.
New
What you got, Max?
research published in the journal Science has revealed that scientists who use large language models like ChatGPT are producing significantly more scientific papers. The technology is also helping researchers whose first language is not English. The growing use of AI in scientific research has sparked concerns about spurious findings and that the machines are simply making this shit up.
Yeah, maybe. I mean, who knows?
Yes.
Maybe Chat's just got a sense of humour.
To quantify the effect of AI on scientific publishing, researchers from Cornell University, QS,
Now,
6.
it's sub 20,
6. I think it's 12 or 13.
it's
go down.
16,
Gotcha.
and the University of California, Berkeley,
Oh, God, they're good
QS
too.
ranking
2.
4.
2.
one more than Cornell, 17.
17.
They analysed over 2
They are good unis.
million study abstracts published on 3 major preprint servers between
2 million?
2 million, yeah.
So they also used a
Yes,
large
they
language
did.
model then, yeah. That's because they didn't do that by hand.
Between January 20...
I was going to say using AI to peer review AI is the worst. And it seems like they've just done that. So thanks, Science, for publishing this.
So it's like 6 years worth of papers. They were posted before they underwent peer review. To perform their analysis, as Peter said, the team used ChatGPT to generate AI-written versions of abstracts before 2023. They then checked the AI writing for patterns that distinguish it from human text. With this baseline, they created an algorithm to scan newer papers for similar patterns to flag AI-assisted work. They also tracked authors over time so they could measure their frequency of publication. They found that when scientists use AI, their productivity increased. The biggest jump was in the social sciences and humanities, where output increased by 60%.
Interesting, given it's the humanities. Humanities.
There's no AI in
Interesting.
humanities series. While
Well, it just seems odd. Seems all that's the one that skyrocketed. In biology, I feel like it's fair because we just use it to count stuff. What are they doing?
While biology and life sciences increased by 53%, meanwhile, physics and maths, the boring ones, the scientists reported receiving a 36% boost.
Right.
One of the most fascinating findings was the massive increase in productivity from non-English speaking countries. The more distinguished science journals require manuscripts to be written in high-level English, which has long disadvantaged scientists from non-English speaking countries. But with AI handling some of the grunt work, researchers from Asia saw their output jump by as much as 90%.
Wow.
Yeah. So the studies...
That's a real benefit. It's because we would be missing out on so much good science just because of a language barrier.
Yeah.
So that's a really good benefit of that. The other stuff, the humanities, I'm squinting at. I'm confused about that one.
Yeah. Anyway, the study found that the more complex the AI-generated writing was, the less likely the paper was to be of high quality. The clear message from the study's authors is that we can no longer judge a paper by how smart the language appears. To safeguard scientific integrity, the researchers proposed several measures, including that institutions implement deeper checks and even specialised AI-based reviewer agents to help distinguish between human and machine-generated writing. Which brings me to this ABC article that was released on Monday by Julia Bergen. And she's quite funny because she uses a lot of M dashes in the article, which is quite cool. So, for those unfamiliar, M dash is sort of like a longer dash that AI loves to use.
Well, it's grammatically correct. That's the thing. Is people who love grammar are quite annoyed about this because they've been using it forever, and now it's come up as an AI thing just because it's technically correct, but no one does it because it's annoying to find on the keyboard.
Anyway, this happened at a New South Wales school. An AI detector tool had incorrectly identified Gabe, Gabe's year 12, not this Gabe, but another Gabe, his year 12 work as AI generated. The 18-year-old was pulled out of class and kept after school to prove he was not a cheat. He said it felt like an interrogation. Gabe said his teachers wanted evidence, a sentence-by-sentence breakdown of his 3,000-word assessment to show where the information came from. And he comments, I was sitting there with no guidance, trying to figure out where to find all this stuff. He said, I remember my teacher at one point saying, it's okay, we know you didn't do it, but you need to prove it. It's just a thing that we need to do because the Department of Education has told us to do it. So the father got involved in all this sort of stuff. So in summary, the school took 3 weeks to conclude that Gabe did nothing wrong. The Department of Education in New South Wales took 5.5 months to determine the school did nothing wrong.
Oh, my goodness.
And here's the kicker. And the Ombudsman took 4 months to rule it could not make any ruling on the department.
Great. A whole lot of faff for nothing.
Exactly. So,
Goodness gracious.
I don't know. What's going to happen?
I have noticed in a decent number of papers, I really respect the ones that do this, they have a new disclosure at the bottom, at least in the online version of the articles, where they'll talk about AI usage. But I think it's really a good way of doing it because increasingly journals are putting in sort of author contributions at the bottom of the page, like what each author's contributed to, because often a lot of the authors on the paper will be tangentially involved, often will be just sort of from the lab using their name to help get it published, that sort of thing, and do very little in the writing, and so it sort of gives you an idea of who's doing most of the work. But also there's now this AI disclosure thing of showing you what work's being done by that. So I've liked that. I remember reading a paper and it said AI was used to help early stages of doing like working out the coding for the statistical analysis and like an early draft of the methodology section or something like that. I'm like, that's great. If you disclose that and it's not being used in the final product, it is just helping with productivity, which is a huge issue across every researcher in the world at the moment has issues with productivity because of how much work is being expected to do and how much pressure there is to publish as part of that work. Exactly. So if AI can help with that, that's great, as long as it's not being used, as long as it's not
writing papers.
As long as it's not getting in the way of the science being done
and the integrity of it,
and the integrity of that science and the accuracy of that science, and as long as it's being very upfront and about how it's being used, then
and in my opinion, also not. I don't want an AI paper peer reviewed by AI. Peer review's got to stay peer review. It's the backbone of our system.
Yeah.
But how are you going to do 2
it's-
million articles? That's all.
Yeah, exactly.
Yeah, that's why I was like, well, that seems like a lot.
Yeah, and then in schools, I mean, everyone's got opinions on what should happen in schools and universities with testing. It's a whole different kettle of fish, isn't it? But it feels like a lot of the testing is going to go back to the in-person, in-book sort of presentations.
Which I always like.
Tests and essay writing that you can't get an AI in a pen just yet, so it can't write it for you down on paper.
I did get in trouble for having a fountain pen once. They tried to take my ink pot away from me, and I was like, no, I need that to write.
Sonar stands for what, Izzy?
Sonar
What does
stands.
sonar stand for again? From a few minutes ago?
I know what the last word is.
Sonic? I don't, sound.
Yeah.
Okay, I don't know.
And then there's an N word, and then and ranging, and ranging, near ranging. I don't know. Is that it?
I tuned out.
Sound, navigation, and ranging.
I got the first half.
Fair enough. You did.
1 out of 5.
You tune into 4ZZZ, and the show is No Idea with me, Max. We've got Peter. I'm not saying this correctly, am I? We've got Gabe, and we've got our friendly neighbourhood marine scientist.
Do you know what tuna is?
Fish.
It's fish!
Thank God someone's working on this. I don't know what I'd do without it.
Fish are friends, not food.
Great start. Gabe, what does the cat say?
Yeah?
Max, what does the chicken say?
Cluck, cluck.
And Izzy, what does a shark say? All right, as you know, as your friendly neighbourhood marine scientist, I work very hard to put as much marine science into this show as humanly possible. And to that end, because you've been good this year, today's marine science is a two-parter. How exciting, as much marine science as possible. But also because you've been good, I'm actually going to talk a little bit about terrestrial environments as well.
Okay.
Because this week, 2 separate studies have come out, each showing a unique relationship between the ocean and those of us who are not able to sufficiently hold our breath and require scuba breathing apparatuses. Okay. So I thought, as a treat, I might let you choose which one is first. So, Max, S or P?
P.
Okie dokie. So we're going to start by talking about... we're going to go to penguins. That's the P is penguins. These are a seabird, one that can actually swim. Specifically, we're talking about Magellanic penguins in Patagonia. Lots of P's in this one, which they've got so they're called a medium height penguin, which is about up to just above my knee, I'd say, is about that height. They have almost Oreo-like stripes, sick eyeliner, and they've got kind of like a funky little attitude. And these penguins have made a new enemy, the puma.
The puma?
The puma.
Yeah, so pumas were largely eradicated from coastal Patagonia during the 20th century, mainly due to sheep ranching. So people around there were trying to ranch their sheep, they were trying to farm, didn't like pumas because pumas were killing them, and so basically killed them all. Then, in 2004, the Monte Leon National Park was established, which allowed pumas to actually recolonize that space. And they've been doing really, really well. But in their absence, before that 2004 park, Magellanic penguins established a large breeding colony in that area. So before, they'd only bred on the islands just offshore. Now, the reason they breed on islands is because there weren't any big cats or predators that were going to kill them.
Totally.
No predators. So they were like, sick, cool, we'll breed on these islands. And then when the pumas disappeared, they were like, cool, well, I guess we'll come to the mainland now too, and establish that breeding colony of 40,000 breeding pairs, which is unusual for a species that typically nests offshore. It's huge.
Yeah, right.
But now the pumas have returned, and as somewhat predictably, they have started preying heavily on these penguins, which is a completely new predator-prey interaction. They didn't talk before. This is completely new. So researchers were like, let's go study it. Apparently, so they'd heard some rumors of people seeing pumas eat penguins, and I think that's when they were like, okay, we've got to get on this. They'd heard a little bit about it, and then they did this multi-year field study in the Monte Leon National Park in Argentina from 2019 to 2023. So they did a couple of different things. Number one is they did a bunch of different camera traps. So it's called a grid. So essentially all of these cameras, they're called camera traps because when they sense movement, they start filming. And they did 32 camera traps in a grid. So that covered a 2-kilometre stretch of coastline, with all these cameras, essentially. 2 kilometre stretch coastline completely covered by cameras.
Yep.
Really cool. They also put GPS collars on 14 adult pumas to see where they were going and how they were moving, which is really, seeing the pictures of them adding the collars, like I know that the pumas have been darted, but it would be such a good opportunity to have a little cuddle with a puma, you know? I love big cats. I know that I couldn't survive a big cat attack, but they just look so cute. Like, why don't you just want to give it a little scratch behind the ears while you add the little collar on. Anyway,
what colour
then
are the collars?
this is why I would never work on big cats. I wouldn't be allowed to. I'd be way too tempted. And then they did kill site investigations. So when there was penguin predation, they would go and look and confirm that it was pumas eating penguins. So the pumas were classified into 2 different groups, penguin eaters and non-penguin eaters.
Okay.
There were 9 penguin eaters and 5 non-penguin eaters. I guess that was just preference. Personally, I wouldn't want to eat something feathered, so I kind of get it. So penguin-eating pumas strongly concentrated their activity near the penguin colony during the breeding season. They actually expanded their home ranges by 2 times the size when the penguins weren't there. So when the penguins were there, they just shrunk their territory hugely because they didn't really need to go anywhere else. They just stay by the penguins.
Right.
The non-penguin-eating pumas had a more stable, typical large territory year-round because pumas just travel and eat what they can find. But one big thing you need to know about pumas is that they don't like other pumas at all.
Okay.
They really dislike being around pumas. They would much rather just be on their own. They're kind of like a house cat in that way, not that they're very closely related, but they just don't like other pumas. And so they were like, usually you don't see them interacting. They have their own territories and they stick to that. When the penguins were there was a striking difference in social tolerance between the penguin-eating and the non-penguin-eating pumas.
Grumping. Nice.
Those, exactly, same sort of idea. So the penguin-eating pumas had 254 spatial temporal encounters, basically meaning they met up about 254 times. And they said vast majority were completely passive, not aggressive, having a fine time. Whereas the non-penguin-eating pumas, in that same time period, there was only 4 encounters. So 250 more in those 8 penguins.
Yeah.
That's huge. An absolute... you don't see numbers like this very often. That's a crazy difference. And most encounters occurred within 1 kilometre of the penguin colony. So they say that this level of overlap is so unusual for adult pumas. You just don't see this with them. So they think essentially what is happening is sort of scrumping. Although they're not sharing, let's be clear here. They're just not really caring when someone else gets a penguin.
Yes.
That's the main thing here.
Okay.
So basically, they say that because penguins provide predictable, seasonally abundant and spatially concentrated food sources, the pumas just kind of are okay with each other during that point. Because there's no reason to not be.
Are the penguins alcoholic or not?
Haven't heard about it. I don't know how they would be because you'd need alcoholic fish, which hasn't happened yet, but maybe one day they will. But yeah, the other cool thing here is that the puma density near the penguin colony was more than twice the highest previously recorded density for Argentina. So they've had pumas everywhere for a very long time. But because they don't like being near each other, having a high density of pumas is wild. So that was really crazy.
And I just had a look at the breeding seasons for the pumas is also when the penguins are breeding and would be onshore. So it's not just it's a pretty intense time of year for the pumas to be near each other.
It's a big time of year, exciting time. Everyone's getting together.
So cool. Like that scrumping stuff that we've been talking about, and those capuchin monkeys in Central America. Amazing all the stories have come out this year of when these complex vertebrate animals have
social behavior,
abundant food, and the shark feeding that you talked about. Multiple
whenever there's abundant
occasions.
food, behaviors change significantly. And that's sort of what they wanted to talk about here, is because in reality, this relationship between the penguins and the pumas would not have happened if humans hadn't eradicated pumas in the first place. Penguins never used to nest there because of pumas. So this whole thing is a reaction to human-altered landscapes and how they reshape animal behavior.
How long are the penguins going to last now?
Well, so this was another thing they said, is that they've been sort of looking, and because the breeding colony is so established now, they haven't seen a huge reduction in numbers of the penguins yet. There was a reason they didn't breed on the mainland in the first place, but now that they're established, it's kind of interesting to see what's going to play out from here. This is a completely new predator-prey interaction on the globe. So Interesting, a little depressing because we made it happen, but really cool to see. This is just my first example for today of how the ocean and its plenty affects the land and how they interact.
It's no secret that the MotoRap is a somewhat divisive segment.
Yes, within the team.
Yeah, but
one person, me, does not like it.
But it does tick the box, the STEM box, and like science.
Does it?
Yes,
Where?
science,
when do we talk about it?
Science, technology, engineering, and motorsport.
And when do we... Oh, right. I see, we've changed the acronym.
STEM.
You got me right before I riled up.
You're tuned to 4 Triple Z, and the show is No Idea. With me, Max. We got Gabe. We got this.
Okay, it's time for the best part of the show. Loosely defined as science, yeah, you already know. Everybody listens to 4 Triple Z just to hear us talking about what Butters just did. Subscriptions just keep rolling like the tires on a car. But something tells me that our science covers won't go far. But unlike an engine, I will keep you in suspension. We're all here to hear him talk, so let's give him attention. You're not ready for when he starts rapping. Gonna hand the mic to Max, and I'm not talking Van Stappen.
It's the second last episode of MotoRap for this year.
It is.
F1. Hit us up, Gabe.
Max, there's some big changes slated for 2026 in F1. It goes through its eras, and we're about to launch into a new one. It was delayed because of COVID-19. They pushed it back. So it was going to be this year, right? And they pushed it back to next year.
Yeah.
And so there's a whole bunch of changes coming through, which means the whole of the Formula One look and feel and how they drive and everything will be quite substantially different to how you've potentially gotten used to it over the last few years in the Drive to Survive era of ground effect cars, big ground effect cars. We'll get into what that means and how it's changing. For a start, the big one that I think will be the most notable change is that the cars should look smaller. Probably. The wheelbases are changing. That's the actual size of the car adds in the wings, which are also changing, and other bits and bobs. But the wheelbase itself, where the wheels are positioned relative to each other, is smaller. So the width is going from 2 meters down to 1900 millimeters, so dropping by 10 centimeters there. And the length is going from 3.6 meters to 3.4 meters. So that's dropping by 20 centimeters. So a small reduction, but noticeable. The tires are also changing as part of this. They're still 18-inch Pirelli tires, but they're narrower.
Yes.
So they're getting more narrow, the
smaller
tires.
footprint on the road.
Exactly, a smaller footprint on the road and a smaller car overall. They're hoping that this will drop the weight from 798 kilograms to 768 kilograms, taking about 30 kilos off the car, as different other bits are coming off and other bits are getting added back in as well. But overall, particularly with those overall size drops, it should reduce the weight by 30 kilos, which there's some rumors already going around that a bunch of the teams are already over this in their current draft versions of the cars. We'll see how true that is. I believe at the start of the last regulations, the weight limit actually got increased after close to the start of or shortly after the start of those new regulations coming into place, because the teams were struggling so much. So we'll see if they stick with 768 kilos, but that's what they're currently aiming for. The other big change is they're trying to shift the focus from ground effect, the massive amounts of work they do in the current era, or have been doing in the current era of cars, to put in just an incredibly complex bunch of aerodynamics going on on the bottom of the car. We often saw at the start of every season, the first time a car would hit the wall and get lifted up by a crane.
Everyone would be looking.
The amount of photographers who knew that they would be paid a pretty penny for good photos at the bottom of the competitors' cars from other teams to see what they were doing to help them run a low car that would just suck down onto the ground really effectively and move that air as effectively as possible to suck it down and give it that downforce. It helps get the power and the braking onto the wall. Yeah. So that is meant to be reduced. Overall, they're estimating about a 30% reduction in downforce, and a 55% aero drag reduction as well. So they're hoping that will lead to higher overall speeds and also better fuel economy and potentially better overtaking. This is a lot of the rules. If you read the official versions, it's to help with overtaking. If you read pundits having a assessment of it, they're very less convinced that it will help with overtaking in the cars because the teams are just so good at exploiting the rules to make it harder to overtake, but also just better for themselves in their cars, which makes dirty air behind them and harder to drive into when you're following. But that's the idea, is they're meant to be reducing downforce. The cars themselves will probably be lifted, which they're hoping will suit more driving styles and be a bit more open to different people being better at different circuits. But the implication there being that some of the drivers that are succeeding now are probably better at this high downforce driving that they've got in the current cars, and maybe lifting them a bit will open the door to different driving styles succeeding at different circuits.
Yes.
We'll see if that actually happens. And then the power units are changing as well. So a big change here is that it's the same V6 single turbo. So same sort of internal combustion engine, but the power outputs are changing between that and the battery. So in the current version of cars, 560 kilowatts comes from the ICE, the internal combustion energy power, the engine, and then that's dropping to 400 kilowatts. So big drop. And then the battery output, the electrical power output, has gone from 150 kilowatts to 350 kilowatts. So close to 50-50. Still a bit more on the internal combustion engine, but close to 50-50 between that and the battery, the electrical power output. So that's going to be very, very different. Added together, it should increase the total kilowatts available in the cars from 710 to 750 kilowatts. Again, hopefully helping with top speeds,
and
high top speeds, and overtaking, because they're lighter and have more power in them. So that's all, really cool to see. And then on the back of all of that, because there's so much more focus on the battery, that's going to change how they run the overtaking assistance. In the previous few years, that's been called DRS, drag reduction system, which is just a flap on the back of the car that they open in certain sets of straights on each circuit when they're within 1 second at a marker before that straight. They open the back. It effectively means there's an air brake on all of the other cars, and they're able to disable that brake, open the flap, and go a bit faster.
Like 15
when they're within,
per hour.
When they're within a second of the car in front, and help them overtake. That's gone. No DRS. No flap opening. There will still be flaps. They're allowed to use active aerodynamics now in part. So on the front wing, you'll see this happening. All the teams will have it going the whole time. So they'll have the wing pushing up and helping with braking into a corner, and then should be opening up on when they're trying to accelerate out of a corner and on straights. So we'll see that. There'll see some flap action going on with some active aero. It'd be cool to see that coming in. They've been a bit hesitant of introducing that for a variety of reasons, but one was because they needed the DRS as an overtaking assistance. So instead, it's being replaced with battery-based overtaking assistance. So it'll be interesting to see how that works. They're basically going to have this overtake mode that they can activate when they're within a certain distance of the car in front. That distance, I believe, will change based on which track they're at to try and suit that track specific needs. And it will basically mean that there is more electrical output available for that car throughout the whole lap, which they can apply as they want. There's a lot. I looked at the regulations. There's a lot of detail about what speeds different amounts of assistance kick in. It is still built for higher speed help. Like you get the best bang for your buck when you're going 350k or 355k an hour. Down the straight, at the end of the straight, that's when the biggest power output difference there is between you following and the car in front of you. But it's available across the lap. There is a difference. So it should also help with them staying a bit closer through the corners, which has been an issue in the current versions of the cars, that they fall too far back through the corners because they can't stay close to the car in front with all the choppy air it's putting off. And then they'll also have boost mode where they can press a button and boost their battery as well, which can be used defensively as well as
that's true.
Offensively. So lots of focus being put on these batteries and how effectively they can get the power out of those batteries and use the extra boost. And we'll see if we end up forgetting DRS or really longing for it to come back over the first few races. And we'll see how good it is to improve the overtaking going on. The other big changes in the fuels that's going into the internal combustion engines is all biofuel now. It's sort of been positioned as a sustainable fuel thing. not that Formula One is anywhere near sustainable as a.
They've got a pretty big carbon footprint.
A big carbon footprint. I was impressed. They have reduced their carbon footprint a bit. Since a few years ago, and they pledged to go carbon neutral by 2030. That doesn't include all of the extra stuff of everyone flying to the event to watch as spectators, and all. Just within what they track, they're saying they're going to go carbon neutral by 2030, and they're going to put in biofuels, which has been met with a mixed response. Some people say it's a bit greenwashing in feel, and it's potentially reducing the speeds that the cars can go and how effective they can drive. But they're trying biofuel, 100% biofuel. Each car manufacturer has partnered up with a fuel provider, so there'll be different types of fuels going in based on which provider they've gone with. That's recently been announced who everyone's going with, so it'll be interesting to see how that plays into it. They'll be using different fuels from different people, and they've all got to be biofuels, so that will change things. And then beyond that, there'll be just changes to all the teams adapting to these new regulations. There's lots of other little things going on in terms of what they're allowed to do on the base of the car now, and with the new flaps, with the new wings, they're meant to be simplifying the wings, but also adding active aero. So there'll be lots of smaller changes going on as well. And the teams will be actively developing those cars over the next few months. The wind tunnel time will be huge for a lot of these teams. It's the worse you do in the season before, the more wind tunnel time you get allocated.
Yes.
It's all very specifically tracked.
Looking at you, Alpine.
So Alpine, who finished last, the Renault-backed Renault Alpine team will have the most time, and McLaren will have the least time, sort of inversely proportional to the prize money. So it'll be interesting to see how much of an impact that makes for those teams down the back, and if they are able to get a bit of a leg up in this new era of different regulations and being able to test more stuff in the wind tunnel. And then there's very specific rules about how they're allowed to test the cars on the road as well. So we will see in Bahrain, which is the end of February or mid-Feb, when they're putting them on the road, they'll do some testing. We often don't get a full picture of what the cars can do in those tests.
When it's a public test, they hold a lot back, That's why they're doing some private testing at Barcelona before that.
Yes,
and apparently that's when they're going to bring their actual car to do some testing, so there's no cameras taking any photos of them.
And then the first race will be in Melbourne, early March from memory. And what we'll also see throughout the next month or so, or maybe 2 months, is the teams showing off their cars for the first time, which, of course, there's no requirement that the car that they show is the car that they bring to the first race. But it should we'll get an idea of what these new cars will look like, because they'll probably be basing it a bit off the new regulations with the smaller size and different types of wings. So it'll be interesting to see how this plays out over the next few months, but it is a big change to Formula One, and it should lead to some very interesting early season action as all the teams get a sense of where they're at after this squabbling for many of them years, but for a lot of this year and over the next few months, getting those cars finished and ready to race in a very different era with big batteries and smaller cars and more power output and less downforce, and we'll see how they run.
Now, Mercedes boss Toto Wolff, he's quite bullish about the new regs, and probably not next year, but the following year once they get a handle on what's going on. He reckons the cars should go quicker than this. Back in the day when the Mercedes were very quick, I think Valtteri Bottas set the quickest time in a race, quickest speed. That was 375 kilometers per hour
right.
down Baku straight. And so Toto's now thinking that the cars might even hit 400 kilometers per hour. So that should be exciting to watch.
Good dude.
Okay, that's it for the MotoRap this week. You're tuning to 4ZZZ. And the show is No Idea, your weekly dose of science with me, Maxwell Gabe. We're our friendly neighbourhood marine scientist with part 2 of this.
Tuna is.
Fish.
It's fish!
Thank God someone's working on this. I don't know what I'd do without it.
Fish are friends, not food.
Great start. Gabe, what does a cat say?
Yeah.
Max, what does a chicken say?
Cluck, cluck.
And Izzy, what does a shark say?
Their mic's not on.
This is
what always happens because I don't participate in F1 for moral reasons. And now I'm back. I'm back. We're back to the science. We're here. Don't you dare. We started on the shore. We started very terrestrially with pumas. We moved sort of onto the coastline with penguins. And now we're going from that coastline and into the ocean. Now, I would still say penguins are marine creatures because they can swim. But here we're going from shore to sea. So in the sea, our S, I said it was between S and P, S is sharks. So if you had a list of shark prey, what do you think you would think of?
A list of shark prey?
What do sharks eat?
Fish.
Seals.
Yeah, it's another S one. That's good.
Small whales. I don't know.
Yeah, small whales. Correct.
Dolphins.
How soon do you think you would think of seabirds?
Yeah, true. Okay. No,
Yeah, right.
Not very
It
often.
doesn't seem.
Okay.
It's not something you think about.
No.
Sharks eating seabirds, but they actually
Sharknado.
do eat them.
Yeah.
That's right.
Yeah, and that's the only way they do it is they become a NATO and then they
Get
go and
stuck in
eat
a
birds
store.
while they're flying. Actually, if you look it up, there's some really cool photos of sharks eating seabirds because usually it's when the seabirds are sort of diving and not always when they're in the water. Sometimes it's when they're above the water. The sharks just come out and grab them.
Nice.
So it's a real kind of a fun like aiming situation there. But they do eat them, and a new study shows that seasonal seabird nesting can actually reshape the movements of sharks. This is another seasonal nesting thing.
Okay.
Like the penguins were nesting, this is a seasonal seabird nesting, and the sharks move from them. So essentially, predator movements are often studied in isolation, right? So you're like, well, where is this shark moving? Where is this tuna moving? Blah, blah, blah. But ecosystems are interconnected. Our whole job is to look, as ecologists, is to look at the system and how does the system move. And so scientists wanted to know whether a seasonal terrestrial food source, which is young seabirds, could influence where sharks move and how other predators respond to their presence. So researchers from the University of Hawaii at Manoa, QS ranking,
Oh, we've
please.
done this before. 120.
We have.
150.
122.
They're 546, but I will point out that the University of Hawaii at Manoa is very, very highly ranked for marine science.
Yes.
So
yeah.
different ranking system as compared to the whole university. You can't expect them to be amazing at like what savannah science, can you?
And those are the two far ends of the
That's it.
spectrum of
That's
what you can
all we
study at university: marine science and savannah science.
Yeah. So they were looking at the remote waters of the northwestern Hawaiian Islands, where fledgling seabirds become a seasonal food for tiger sharks. So over 2 years, they tagged 128 sharks with acoustic transmitters. They looked at tiger sharks, grey reef sharks, Galapagos sharks, a bunch of different sharks. And then they compared the shark movements. So between the summer season, where the seabirds were fledgling, and outside of the seabird season. And then they also did fish surveys to sort of rule out whether it was their normal prey availability. Because as much as I've said that sharks eat seabirds, fish are way easier. They mainly eat fish. Fish are far more available to them than birds, funnily enough. The fish of the air, we might say.
Chicken of the sea.
So yeah, chickens of the sea. That's what fish are. So they looked at all the fish around to make sure that it wasn't some other sort of prey that was changing what they were doing. So, and this is what they found. During seabird season, the tiger sharks clustered around the small islands to hunt the fledgling seabirds because as they're a little younger, maybe they're not the best at getting out of the way very quickly.
They'll crash into the water a lot as they're learning to fly off the islands too.
Nice eating for tiger sharks. So they'll go and actively cluster around those islands to hunt them. And the interesting thing is, grey reef sharks completely avoid those areas at that point in time to avoid predation risk. So one of their other prey species just gets the hell out of there. They're like, no way, there's way too many tiger sharks here, we're going to move. And Galapagos sharks shift their habitat use to sort of reduce the competition. All of these three main shark species are all moving around because of the seabirds, because the seabirds are there. So when the seabirds leave, the tiger sharks move on, and I assume, like the pumas, have a bigger habitat, a bigger range again. They're not going to keep looking at that one thing. They're going to move around. And they found out that other shark species also return to their usual habitat. So it's essentially, as soon as the seabird's there, they all kind of pack up and move to different locations so that they form essentially a brand new ecosystem of how things run. They did confirm that it wasn't other fish. It was just this competition before seabirds and predator avoidance of the tiger sharks. That was it. There's plenty of food. Their regular food stayed about the same. It was just the seabird influx of these new baby fledgling seabirds. And so it shows how seasonal events on land can cascade through marine food webs. And it highlights the role of seabirds as ecosystem drivers. They're not just prey. They're shaping an entire ecosystem from the bottom up, which is really cool. And it sort of demonstrates how apex predators like tiger sharks can indirectly shape the behaviour of other predators around. Yeah, so there is a little bit of a concern that that seabird nesting habitat is reducing, so it's declining, especially after things like Hurricane Walaka in 2018. And they think that could destabilise this sort of like very tightly linked systems. But yeah, that's yet another example of how the land and the sea are interacting. They also want to say that in places like Papahānaumokuākea, which is one of the big marine parks in the area, is a hugely important part of this relationship as well. But it shows how that's protecting the marine environment, but these seabirds may not be protected because they've had hurricane damage, they're losing their land. So with that interactivity, we can't just protect one or the other. You've always got to have a bit of interaction and understand how ecosystems work. Like the ocean doesn't stop at the shore and the land doesn't stop at the waves. They all work together, which is a really beautiful story. And it was just cool that both of these things happened in the last week.
Yeah.
Two really good examples of how predator and prey and food webs go across the shoreline.
Be cool to track it even further down and go, okay, what were the sharks that left? What are their prey doing at this time? Do they move in?
Do they go, well, maybe I should move to where the tiger sharks are because they ignore me. Like if I was a fish, I would go there. I'd be like, hell yeah, they're preoccupied by these diving birds.
Yeah.
Fantastic.
Amazing.
Yeah, because dinosaurs did not go extinct. We know that. Not dinosaurs. Many dinosaurs went extinct, but dinosaurs did not go extinct. We have them all around us. They're called birds.
Yeah.
I just like to really lay down the law there.
As a
marine scientist.
As a marine scientist, I'm here to talk
We
to
got
you
birds.
about birds.
That's it.
Yeah.
The fish in the
and it
air.
may have not been a meteorite.
So you tuned into 4 Triple Z, and the show is No Idea. With me, Max, we've got Peter, and we've got our friendly cook.
Australia's first MasterChef has to have that kind of genius.
Understanding the science allows you to think of new things to do.
It's still moving, is that wrong? Anyone can cook.
No soggy bottom. All of the creative stuff won't work unless you've got an absolute solid foundation. That's so important.
The science of cooking, Max. It's been a while. It is back for a Christmas special or any other meal you're cooking up for a lot of people over the next few days. I've got 6 tips. I've gone through and pulled some weird little science tips out of how you can improve the big meal. And so I'm going to run the big meal. Whenever you're having it over the next few days, few weeks. The first one is if you're trying to get alcohol out of a sauce. If you're trying to cook something down that's got a bunch of wine or something in it, and you're trying to cook it down for the kids who are there or anything else, we'll get to this fire. We're going to get to the Christmas pudding fire. That's what we're finishing on.
Oh, the grand finale.
Oh, yeah. I've got the proper science on that one. But a 2017 study in food chemistry recommended if you need to get alcohol out of a sauce, for a start, you can just simmer it for a while, but put the lid on the pot and it will increase the amount of alcohol coming out because it will increase the amount, the heat in there and help it evaporate off. And then as long as it's a lid that has like a hole in it or comes away from the pot, it's not too heavy or too sealed on, the water will condense on the base of the lid and the alcohol should evaporate out the side. So it'll mean you don't lose water while still evaporating off the alcohol. So that's my first tip.
I also, secondary to that tip, just accept you're going to have a bit of alcohol in your food. I've covered this before. You don't completely lose all of the alcohol. You're just going to have to live with it.
Oh, yeah, you very rarely will get all of it out, but that will help, putting a lid on. Number 2, make sure you're searing meat before you cook it for a long time. Especially if it's been recommended in the recipe you're following, definitely do the sear. The 2023 paper from University of Washington physicists had a whole bunch of recommendations for cooking stuff, but this one was to get the perfect meat. They were looking at steak in particular, but to get it, you need by searing it in a really hot pan. So you need to make sure the pan's hot first. The proteins on the surface of the meat will coagulate, and as they do that, it'll seal moisture inside for the rest of the cook. So it doesn't just give you flavour; it seals in the moisture
on a non-Teflon pan.
No,
genuinely, because they'll get beyond 270 degrees and then it's not good for you. So stainless steel, cast iron, something like that.
Number 3, you got a cutlery preference for Christmas?
How do you mean?
I have really intense cutlery preferences.
Well, like, do you have
the good silver?
Yeah, you sit down. Is there anything that you go, oh wow, that's good cutlery?
Yeah. Lots of different things. The handle's got to be well balanced. The prongs can't be too far apart. A spoon has to fit in your mouth. It can't be too deep. It's got to be a good shape. There's so many different things that go into cutlery.
Look.
Couldn't care?
I eat with fine cutlery anyway, so it's...
Mac could be given a shovel. A shovel to be fine. Max
Shovel
is up
might
here.
work because
I don't want
according to a 2015 study by Oxford University researchers, they had 130 diners. They gave them a fancy meal using lower quality cutlery and then the
is this about
fancy
the weight?
stuff, and then use the fancy stuff. So same meal, same setting. Some of them had the sort of behind the scenes, back of house staff cutlery, and then the other ones had the fancy stuff that was 3 times heavier. And they said that they thought it was more artistically plated. They liked it more. It was trout with mashed potatoes, spinach and caper, and brown shrimp butter. If you're interested,
That's good to know.
They thought it was more artistically plated. They liked it more and were willing to pay 15% more of it while eating with heavier cutlery. So heavy cutlery will probably increase how much people enjoy the food. There you go. Yeah. Number 4, this one comes from our Ig Nobel Awards in 2025. The Nobel Prize for Physics on adding starch to cacio e pepe, cheese and pepper pasta. We tested this one out.
A classic
we loved
Christmas
it.
dish.
It was one of the best stories of the year. And it helps stabilize the sauce they found by adding starch. So corn flour, potato starch, rice flour.
In solution, Cool.
So if you're trying to thicken up a sauce that has dairy in it to get it thick, reducing the risk of it splitting, it might be a good idea to chuck a sprinkle of corn or potato or rice starch in there to help
Or make a
stabilize that
slurry
sauce.
first is my recommendation.
always.
Don't just chuck it straight in. You want to
That's
make
right.
it into a slurry.
Yeah. And if you do have cheese that's going into the sauce, what this one did was actually blend it into the cheese.
Yeah, with a blender. We mean blend.
I know.
We did it.
The pasta water or whatever water you've got.
Yeah.
A bit of starch and the cheese, blend it up and then pour that into the thing. Number 5 is the first of my 2 bits of Christmas pudding science for you, which is on the coin. So Nathan Killer, a chemist at the University
I was
of...
choked on one of those as a child.
Well, yeah, exactly. A chemist at the University of Tasmania has written a thing up in the conversation this week that includes an interesting bit looking at the coins that people put into Christmas pudding. So it was a common thing to do. Yes, but the thing was in the 60s we changed our coin type. From it used to be a silver and copper base, and now we have a copper nickel alloy. They had the debasement from silver coins. And so apparently the new copper and nickel alloy makes the surrounding pudding green and can impart an unpleasant flavour.
I remember having green.
So instead, it's recommended that you either put in a 5 or 10 cent coin, wash it, and then put it in.
Yeah, maybe please.
Insert it
My grandma
after
never
cooking.
did that.
If you're going to do it, insert it after cooking, and warn your guests that you've done it. You can also you can also buy silver pudding coins.
Right.
You can buy coins for pudding?
That are made from silver, which is what it needs to be. Is the
That's
base.
crazy, man.
So that's your choice. You can put a 5 or 10 cent coin in after cooking, or you can buy a dedicated
Or just
silver
cook them
pudding
first,
coin.
then put them in the pudding.
Or just
That's what they say. Do that regardless.
Oh, okay, good, yeah.
The silver pudding one you could cook it in. But yeah, make sure your guests know about it. And then the last one, number 6. This one has been something I've been thinking about for a long time, which is that when you flame a Christmas pudding, if you've done this tradition, you put some sort of spirit on
Usually
the top.
brandy, but
brandy, a rum. You put it on top. You turn the lights off, you put it on fire, and you get a flaming pudding. But it's like, okay, you don't know when it's out because the flame's transparent for a lot of it. It's a blue flame that's often invisible for a large
You can
part
colour
of
it with like salt or something.
So what they recommend, there's a good recommendation of what you can do here, not salt. And the reason that's going on is because you're getting complete combustion where there's no soot being formed. It's just a beautiful reaction where you're just getting CO2 and H2O as a byproduct, and that's coming off. And so the flame is a blue or transparent look because that's what complete
Just
combustion looks like.
Electrons bumping around. That's it.
To get the more orangey flame in there, what you need is some extra carbon. What's happening happening when you get that burning is you're getting the perfect with the blue flame or an invisible flame or a combination is you're getting the CO2 and H2O coming off as byproducts, which don't really have much color to them. If you have excess carbon in there by adding something like glucose, a sugar.
Oh, I thought you were going to say sawdust.
No,
I wouldn't recommend it, but you could try.
Sawdust. Sugar. Glucose is C6H12O6. So
Yes,
carbon,
correct.
hydrogen, oxygen. When you burn that, the hydrogen likes to go with the oxygen first. It sort of takes first pick and then it leaves the carbon for any leftover oxygen. So by adding glucose, when it burns, most of that hydrogen is going to take up most of that oxygen because you need H2O for water, and you get 12 hydrogens per glucose and 6 oxygens per glucose. So that's a pretty good match for just water, and then you're left with the 6 carbons. It's not always going to be that perfect, but the carbons then are just going to burn. So if they can't get enough oxygen from the air and you're overloading it by putting some glucose in there, then you're going to get soot forming, clumps of carbon with other stuff in there that will then, as it burns, they get really warm and heat up to the point that they glow an orangey yellow color and give flame the orangey yellow color we know.
And I think pudding with sugar sounds nice.
And
It's like you can call it a
right.
brulee pudding, and
Helps
then it's
with
on
a bit
trend.
of flavour. But so that becomes that orangey yellow colour as it goes through the flames, and then some of it burns, and then some of it comes off the top as smoke or soot that then can land on the roof as
And I would
as
recommend
pollution,
that. If
exactly.
you don't mind poisoning your whole family, you could do copper.
gotta
That way
be-
it's green.
Yeah.
It's a fun one, but
Good.
not very edible.
Not very edible. So you can add a small amount of sugar to the
Or a large amount of
spirit
sugar.
and then pour that spirit over the top with a bit, or use a sugar-rich spirit if you're able to find one that says that. Hard to know often. So you can add a bit of sugar. I was thinking maybe you could add like a maple syrup or something that might mix a bit better in.
Or just
to the
icing
alcohol.
sugar. Just chuck icing.
Or just icing
Just
sugar on
put
top.
sugar on the
Yep.
cake.
Yeah.
Yep.
Then
and
pour
then,
the booze
and then pour
over.
that
Yeah,
over.
yeah.
Just don't put too much because otherwise you could get actual browning. Not browning, like blackened burnt bits on it. Or
You
you
get
could
that
release
brulee,
a
Gabe.
bit too much
The least
smoke
favourite.
and set off the fire
Uncle Bob
alarms.
gets that. That's all right.
Yeah. So add a little bit of sugar in if you want to have a more visible flame and a bit more of an impressive flame with your flaming Christmas pudding. And those, Max, are my 6 sciencey tips for
Thank you.
Chrissy dinner or whatever else you're cooking up over the next few days. So they put these 26 babies into these MRI machines,
At
and
the
they were
same
very
time?
proud of being able to get them
That fits.
one at a time.
They're all strapped in a circle around the machine. Sorry.
That's right.
You shouldn't have mentioned babies in an MRI machine. Just
Yeah.
told us that they measured their brains. It's just so funny.
Ready? Tune into 4ZZZ. The show is No Idea with me, Max. We got Gabe. We got Peter. No Idea Space News. You know it.
What you got?
Story of the year for me is a private company that landed on the moon. So, do you remember this?
They've done it again.
Yeah. I've lost you now. I don't know what I did with your image. Anyway, a private company lands on the moon on March 2. Firefly Aerospace's robotic Blue Ghost lander touched down successfully on the moon. It remained operational for about 2 weeks thereafter, allowing the science instruments it carried to do their planned work. This was an unprecedented achievement for private industry and spaceflight in general. Another company called Houston-based Intuitive Machines tried to put their lander on the moon in February 2024, but that vehicle soon toppled over, shortening its mission and those of some of its payloads. They did try a second lunar lander called Athena, and it suffered a similar fate shortly after a touchdown on March 6th of this year. So Blue Ghost's success was also seen as a victory for NASA, which booked the mission via its Commercial Lunar Payload Services Program, or CLPS. And finally, launch cadence. It has significantly increased since 2020, mainly due to one company, and that would be SpaceX. The company is on course to set a new launch record this year of 172. It managed 25 launches in 2020, 31 in 2021, 61 in 2022, 98 in 2023, and last year it did a total of 138. So pretty impressive.
Pretty impressive.
Many.
And the local Gilmore Space added one to the tally of this year, did it not? With a
22nd flight.
Yes. Interesting. How would you call it? A launch?
You call it
Maybe
launch.
not.
How would you call
A
it?
successful test, but not a successful launch.
a test. Not well, they gathered a lot of data apparently. So
They did.
Yeah.
Successful science experiment.
Right up until when it went boom.
It's right.
Hopefully they can do a couple more in the coming years and keep the Queensland space rockets on track.
Yeah, exactly. You tune into 4ZZZ and the show's No Idea. With me, Max. We've got Peter. We've got Gabe telling us why you should subscribe to this wonderful radio station.
Look, I think we all have too many of those emails that say, need a last-minute gift with whatever they're selling. But on a more genuine note, if there is someone who you don't have a gift for for tomorrow or for the next few days when you're seeing them, and you do need something short notice, there is a brilliant option of getting them a subscription to 4ZZZ. If they're a listener, if they're around the Southeast Queensland area or a community radio fan, supporting community radio, getting them a gift that means that they get they go into running to win prizes. They get all sorts of exclusive access to stuff and early access to stuff. Their name pops up when you text in. You get when you request a song, we try as hard as we can to get every request from our subscribers played.
Even if it's at the end of the show, hey Max.
Even if it's right at the end of the show and you squeeze it in under the wire. And the subscriptions do legitimately keep us on the airwaves. Community radio is not possible without people buying subscriptions to keep us going.
You didn't even mention the best part though, Gabe.
And if you subscribe this month, you go into the running to win.
Oh, that was not my point, but you do go into the running to win our monthly sub prize every month.
You're talking about the Warm in a Glow.
I was talking about the Warm in a Glow.
Nice.
Nothing can beat it.
Nothing can beat it, and nothing offers you that. You can, everyone's emailing you with those last minute gifts, and not one of them offering you a Warm in a Glow like we're offering you. And uncancelable, wonderful entertainment every single week. But if you're in it for the monthly sub prize, which is pretty good, this month of December, we have a fantastic sub prize of $250 to use at your pleasure at the End Bar in West End, an institution. It is cozy and charming. It is a perfect place to get some lovely cocktails, natural wines, craft beers, good place to hang with your mates, with your friends, with your family, with all the people you want to be cozy with at this time of year. Again, your subscription, and you might win $250 to go to the End Bar, or just go yourself with your own money. It's a great place to go.
And you have to visit our website if you want to subscribe at 4ZZZ.org.au/support. If you're under 18, it's $25. If you want to subscribe your pet for Christmas, $25. Concession.
And that is a wonderful gift to give your pet. Everyone gives their pet a gift this year, this time of year. Get them a 4ZZZ subscription. You'll never know how much they'll appreciate it until you do.
Concession $40. Full is $80 per year. A passionate $140, or super sub. Get your name written downstairs for $500.
And that is about all we have time for this morning. Thank you to all those subscribers of 4ZZZ who do quite legitimately bring you this show and all the other shows on Z every single week and make it possible for us to make this radio. You can become a subscriber at 4ZZZ.org.au. It's on that website where you can also listen back to the full recording of this show with all the music, as well as a bunch of our previous shows. The condensed version is available on your podcasting platform of choice. To search No Idea 4ZZZ. That's No with a K, No Idea 4ZZZ. Thanks to Toby for editing that up. Thanks to you, Max and Peter, for your stories this week. We'll be back in your ears next week. Between now and then, check the AI disclosures on any papers you're reading this summer. Watch those PFAS levels in your seafood. Add a pinch of sugar onto the top of your flaming pudding. And watch us back on socials. We're at No Idea 4ZZZ.
Well
right
played.
now.
And we'll speak to you next week. See ya.
Bye.
Bye.
I'm a goddamn marvel of modern science.